Hello class, we're about to start lesson 10, compare proportions in different formats. The relative magnitude of two quantities can be represented in multiple ways, as simple numbers on a graph or chart, or as dimensions on a blueprint or diagram. It is harder to compare two quantities when they are presented differently. For example, when one is represented on a bar graph and the other is represented in a table of values. To directly compare quantities represented differently, translate them into the same format. Typically, using a numerical representation is most efficient for both translation and comparison purposes. The bar graph shows the number of accidents for men and women aged 18 to 35 in Tabular County for the summer of 2014. The following year, the county released a report that the monthly rate of accidents for men in 2015 had been 1.6, 2.3, and 1.8 times that of women for June, July, and August, respectively. Of the 6 months reported, when was an accident victim most likely to be male? Okay, now determine the proportion of 2014 male accidents to female accidents from the bar graph. For June, the ratio is 350 to 200. So it's 350 male divided by 200 female, which is 1.75. July is 450 to 200, so we'll divide that out, which is 2.25. And then for August is 200 men divided by 100 women, which is 2. Compare the calculator and give values to determine the greatest proportion of male to female accidents. The highest value for this ratio is in July 2015, which men were, now they rounded this 2.25 to 1 decimal place, to the 10th place, so it became 2.3 with rounding. 2.3 times as likely to have an accident as women. So it would be July. Now it says the following velocity time graph shows the rate of acceleration of two classic muscle cars. A newer model, the Hermes, is able to accelerate from 0 to 60 miles per hour in 8 seconds. Okay, so the dotted line is the pony and the solid line is the Firebat. How does the Hermes compare to the cars on the graph in terms of acceleration? Use the formula for slope of a line. M is equal to rise over run to find the rate of acceleration for the cars on the graph. The pony's acceleration is, now the pony, if you notice here, they use this point 0, 0, and then this point here, which is 80, 10. So they do 80 minus 0 over 10 minus 0, which is 8 miles per hour. And the Firebats is 70 minus 0 over 10 minus 0, which is 7 miles per hour per second. Write the rate of acceleration of the Hermes the same way as 60 over 8, which is 7.5. Compare the values to determine the relative speeds of the cars. The Hermes is faster than the Firebat, but still slower than the pony. Okay, so they tell you here 0 to 60 in 8 seconds. So that's how they get the 60 and the 8. Okay, now it says here, compare the proportional data in the following scenarios. This is the actual set. Now, one thing I want to say, because I know that you all would have a question about the slope of a line. We have not covered slope yet. We're going to cover slope probably in the next chapter. So don't worry about that because I don't believe that you necessarily need slope. And if we do end up encountering that we need slope, then I will show you the slope formula. Okay, now it says compare the proportional data in the following scenarios. Question 1 is based on the following graphs. The two graphs show domestic and foreign sales for a brand of U.S. potato chip. For which year were the foreign sales higher as a percent of total sales, and what was the difference in that percentage between the years? Now they tell us here that this is 1975, and as you can see with this pie graph, The darker shaded area is domestic, and the lighter shaded area is foreign. And if you notice, that's about a fourth or 25% of this circle. So we could say in 1975, that's 25%. So now we have to see what percentage this is in 2005. So in 2005, we notice here that the foreign is 2.5 and the domestic is basically 5.5. So what we want to do is this here. We're going to write this out as a proportion. So we're going to take the 2.5 for the foreign, which we have here, and then we have to do total sales here. So 2.5, and that's about 5.5. 2.5 plus 5.5 will be in your denominator. So this will give us 2.5 over 8.0. So now we would convert this to a percent. So we would take our calculator, press N over D, add 2.5, and then in our denominator we add 8.0. Hit the right arrow and press second and a closing parenthesis, and then press enter. And that will give us 31.25%. Now remember, we said with this circle graph here, this is about 25%. So that lets us know that with this question here, we said for which year were the foreign sales higher as a percentage of total sales? So that would be 2005. So our answer here would be 2005. That's the highest year. And then it also asks us what's the difference between the years. And what was the difference in that percent between the years? So we'll take our 31.25 and minus 25. Because remember, we said this is 25%. So that would give us 6.25%. So the difference would be 6.25%. So the answer would be 2005, 6.25% being the difference. Okay, now that took care of problem number 1. Now we go here to problem number 2. Question 2 is based on the following graph. So we see we have this graph of the second grade election results. Now, a second grade political candidate, Rex Slater, predicted he would win 55% of the class vote. The results of the election are shown in the bar graph. Was he correct? So we take the number of votes that Rex got. Rex, it looks as though, has 9 votes. So Rex has 9 votes. So we're going to do this as a proportion. Rex has 9 votes. Now we have to find the total for the class. So we got 9 here, plus 4, plus 6. 9 plus 4 plus 6 will give us 9 over 19. Now we put this in our calculator to find a percent. So we'll press N over D, 9, down arrow 19, right arrow, second, right parenthesis, and press enter. So it's about, if we round to the nearest percent, it's about 47%. So Rex said that he will win by 55% of the class vote. He did not. He only won 47%. So the answer is no. He was not correct. All right, now we go here to question 3. Question 3 is based on the following graph. It says engineers at an automotive parts company are testing brakes to find out whether their brakes beat those of their competitors, which can decelerate the same car at a rate of 15 miles per hour per second. Which statement correctly describes the results of the latest test shown on the graph? Okay, so I have to show you all the slope formula. I was hoping that I could wait to show you all that to the next chapter, but apparently I cannot. Okay, so slope is usually denoted by the letter M. Slope is equal to, we saw this, rise over run, which is the same thing as saying y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now, I know this may look foreign to you, but just give me a second. What happens is this here. You need two ordered pairs on a graph. Now, what we have here, we're going to use the ordered pairs on these graphs. It doesn't matter which is first or which is second. So let's use the 0, 50 as first, and then the 3.50 as second. Okay, so we have our 2 points. Now, x is always the first value. So x is always the first value. Y is always the second value. Now, if you notice here in this formula, I have a sub 2 and a sub 1. All this is telling you is what parenthesis to go to. Everything in the first parenthesis are your sub 1s. So x sub 1 and y sub 1 is in the first parenthesis, or as we call them, ordered pair. The second parenthesis is your sub 2s. So this is x sub 2 and y sub 2. So these are your sub 2s. So now what we would do, we would substitute. Y sub 2 is 0 minus y sub 1 is 50. We substituted. X sub 2 is 3.5 and x sub 1 is 0. So we put in those values. Y sub 1 is 50, y sub 2 is 0. So now 0 minus 50 is negative 50. 3.5 minus 0 is 3.5. Okay? Now, we're going to put this in our calculator. So we will have n over d. We will have negative 50. This is the negative 50 all over 3.5. I'll put 3.2. Okay, now, if you notice here, we got a negative 14.2 and all these other numbers. They wanted us to round to 1 decimal place. So this would be a negative 14.3. So this would be negative 14.3. Okay, now, we're going to take this knowledge that we have here, and it says here, which statement correctly describes the results of their latest test shown on the graph? The brakes are better than the competitor's brake by more than 1 mile per hour per second. Okay? The brakes are better than the competitor's brakes by less than 1 mile per hour per second. And then we have the brakes are worse than the competitor's brake by less than 1 mile per hour per second. And the brakes are worse than the competitor's brake by more than 1 mile per hour per second. Now, we know that with our answer being a negative 14.3. Now remember, it's talking about deceleration, so really it's saying it's decelerating at 14.3. So with that being said, we know that that is not more than 1 mile per hour, because we're told here that the original rate was 15 miles per hour. So that was not more than 1 mile per hour difference. So we would get rid of A and D because they're not more. So we're going to look at these less. Now, if you think about it, they tell us that the car can decelerate at a rate of 15 miles per hour. So if you're trying to stop your car, you want it to stop at the faster rate because you don't want to keep sliding or keep going because you may hit something. So since this only stops at a rate of 14.3 miles per hour per second, and this stops at 15, that means that the original was better. So the new brakes are worse than the competitor's brakes by less than 1 mile per hour. So your answer here is C, is worse. So they will have to improve in order to be able to compete with that other company. Now we come here to problem number 4. It says question 4 is based on the following chart and figure. So we see this chart, and it says a group of psychologists are testing an ancient Greek theory about beauty. According to this theory, the ratio of the height of the face to the width of the face should be as close to 1.6 as possible. The chart above shows the results for some pictures of models in magazines. Given the face shown, determine how beautiful the person is compared to the models. Okay, so if we look here, we would determine, so we would divide. So first thing we would do, we would take the 11 divided by 7, which we have here. So this is problem 4. We would take 11 divided by 7. Now we will put this in our calculator. N over D, 11 over 7, right arrow, then we'll press second, then table, because we want our answer to become a decimal, and that'll be about 1.57. So 1.57. All right. Now, they want us to determine how beautiful the person is compared to the models. Now, if you look here at this chart, 1.57 is actually closer to 1.6 than all of these, because it's only 0.03 away. The rest of these are further away. So basically, this person here is more beautiful because it's close to the 1.6. So we look at A. We look at A here, and not saying that A is the answer, but it says A, the person is more beautiful than any other models. B, the person is more beautiful than 4 of the models. C, the person is more beautiful than 3 of the models. And D, the person is more beautiful than 2 of the models. So your answer would be A, the person is more beautiful than any of the models. So that would be your answer, A for number 4. So this is it for lesson 10. I will upload this to YouTube, and have a wonderful day.